Hello, Latin Geometry students. In this assignment, we are going to introduce area. All right, we're going to do it by starting about two people arguing with each other. They're arguing about who's got a bigger bedroom. And the answer is neither of them really has a large bedroom, just a bed and a closet. But still, they can argue that one of them is larger than the other. How do we measure and decide which room is larger than the other room? Well, usually we start by taking an outline of the room, like a blueprint, and put it over a grid. Now, the different ways we have to measure it. One of them is to measure the distance around the outside of something. In other words, if we count up all these distances, how far you'd have to walk around it, we get something called perimeter. That's the distance around the outside of a shape. To find perimeter, super easy. Just add up the lengths of the sides, 8 plus 3 plus 8 plus 3, and we get 22 feet for the perimeter of the room on the left. When we do the room on the right, we got to add up the sides, 5 plus 5 plus 5 plus 5, and we're going to get 20 feet for the perimeter. So that's one way we measure how large something is. However, that's not usually how we measure how big or small a room is. Usually we measure it in something called area. An area is just a measure of how many little squares are going to fit on the floor of a room. For example, in this first room here, we start counting up how many squares are in here. Now, I know most of you guys know a shortcut already where you can just do, hey, don't I just do base times height or length times width? Yeah. But if you count up the squares, we're going to come back to that in a minute. If you count the squares, we're going to get 24 squares in the room on the left, so its area is 24 square feet. In the room on the right, we get 25 squares, so it's 25 square feet. So when we talked about perimeter, the room on the left was larger, but when we talk about area, the room on the right is larger. We'll come back to those formulas shortly. What are these little squares we're talking about? Well, they can be basically any square. For example, you've been in a room you have in your house or in the school where you see these little square tiles on the floor. If the tile is 1 foot wide and 1 foot long, then we consider this to be a square foot. This is 1 square foot. We usually just represent this with this phrase, 1 foot squared, because it's shorter than writing square foot, but that's how we write 1 square foot. And when we talk about area, we're talking about how many of these little squares would fit on the floor of that room. In other words, say this is the pen outside your house for your dog. If you need to know how much fence you need to build, how many feet of fencing you'd need, that's perimeter. However, if you wanted to measure how much ground your dog has to run around on, that's area. So it's common to take a shape, like in this case a rectangle up on your screen, and need to find the area of this object. Well, the traditional way to do it, though not the fastest, and yeah, I know a lot of you guys already know some shortcuts here, but the traditional way to do it is to lay it on a grid and count how many squares of whatever size they are that fit inside the shape. So in this case, after we count the squares, we get 32 squares. So the area of this rectangle is 32 squares. How big are the squares? I don't know. Maybe they're square feet or square inches or square centimeters. Who knows? We'll get to that in a second. But the shortcut that most of you guys are just dying to get to here is that you can just multiply. Can't we just multiply 8 times 4 and get 32? That's right, you can. We'd use this formula, base times height, which we're going to talk about next, or length times width to get the area. We multiply the dimensions. By the way, since we don't know the units, we don't know if it's feet or inches or centimeters, we just say square units. Units squared here because we don't know if it's in miles or whatever other unit. Okay. So if we want to find the area of a shape, like say a triangle, and again, I know many of you guys already know how to find the area of a triangle, but we can always do this. We lay it out on a grid of whatever size squares we want, and we count up how many squares fit inside it. Now, some shapes don't fit perfectly, where we have some squares inside and outside the shape, and we have to do what's called an estimate for the area. So if we needed to estimate this area, what we would do is try to count how many squares, and probably the easiest way to do that is just count the squares that are more than half full. If more than half the square is inside the triangle, then it counts. So we'd go through and count up how many squares this one would be. And for me, I'm counting up 9, 10, 11 squares. So I'd say the area of this triangle is 11 square units. Now, maybe you disagree. Maybe you got 12. Maybe you counted this up here on top, or maybe you didn't count the little box that the 9 is in, but it's going to be in the same neighborhood. You should be pretty close. Now, there is a formula for finding the area of a rectangle, so you might, or a triangle. So you might think, well, we don't need that. Right, but if we have a weird shape that there is no set formula for, you're still going to have to count up and estimate the area. What's the area for this weird shape over here on the right? Well, again, the best way to probably do this to get a good estimate is to count up the squares. When I do it, I get 18. Maybe you got 17, maybe you got 19, but you should be pretty close either way. Now, we're not going to spend most of our time doing estimates of area. We're actually going to learn how to find the exact answer for the area of all these different shapes you see up on the screens, trapezoids and circles and octagons and all sorts of other stuff. But we're going to start with the most basic shape, our rectangle. And for a rectangle, to find the area, we just do base times height. In this case, that's 8 times 4. You may have learned that formula, or maybe you learned it as length times width. It means the same thing. The words base and height will mean something else when we talk about three-dimensional objects in just a few weeks. But for right now, it's either base times height or length times width. So in this case, we're just going to do 8 times 4, and we'll find that the area of this rectangle is 32 square inches. Now, I'll bring this up, even though I think most of you guys will know this already, because I want to mention that base and height, or length and width, you have to be able to recognize them in a shape. It's easy in a rectangle because the length and the width make a right angle with each other, but they aren't always obvious, our measurements. So a rectangle, if we want to multiply base and height, we have to find these two numbers, and we recognize the base and height, or length and width, because they make a right angle with each other. That's how we recognize which two numbers to use. But if our shapes don't have a bunch of right angles in them, like say this triangle, we may have to draw in a base and a height that'll make a right angle with each other. So that will be something that we have to be on the lookout for when we get to more complicated shapes. And it's not just triangles. There's all sorts of shapes in geometry which don't have 90-degree angles, and we'd have to look for places where we find 90-degree angles to identify our base and height. Okay, so here are 3 short and hopefully somewhat easy problems about areas of rectangles. Take a moment, see if you can answer all 3 of these. Okay, and problem number 1, what's the area of this rectangle? That one's easy. The base and height are 9 and 2. How do I know they make a right angle? It says it's a rectangle, and then the angles in rectangles make right angles. So just do 9 times 2, and we get 18 square feet. Problem number 2, no picture. What's the area of a rectangle if the length is 6 and the width is 10? It's still easy. We're just going to plug it into the formula. It's just going to be 6 times 10, and we're going to get 60 square meters in this case. Number 3 is backwards. I'm going to tell you the area is 24 square centimeters, and the base is 8, so what's the height? Well, we can still do it the same way. Start with your formula and plug in the numbers you know. The 24 is going to go in for the area, and the 8 for the base, so we're looking for the height. No problem. We've solved problems like this in algebra a whole bunch of times. We're just going to divide both sides by 8 and get that the missing height is 3. Next, we're going to do a couple other easy problems just to illustrate a few points here. So starting with this one, this is a picture of a house. This is what's called a floor plan. It's like looking down, and the blueprints looking straight down in the house. We use this to kind of represent or to figure out how big the different rooms are. So this is a blueprint for Max's house. If he knocks down all the walls to make it into one big room, how many square feet will it be? Well, that's really easy. We just add up the areas of the different rooms, and they become one big room. If we do that correctly, we should get 1,000 square feet. In this case, here we have a floor with a hole in it. So it says if the area of the floor is supposed to be 100 square feet, but there's a hole in it. If the area of the floor that's left after the hole is only 85 square feet, then how big is the hole in the floor? Well, in this case, it should be fairly easy. It would be 100 feet. Subtract the hole, and we're down to 85. So how big would that hole be? Yeah, just apply some stuff from Algebra 1, and pretty quickly we should recognize that it's 15 square feet. Okay, for this problem, this pentagon is made up of 5 triangles that are all the same size. Each one has an area of 12 square feet. So what's the area of the entire pentagon? Well, this one should be pretty easy. We're just going to take 5 triangles times 12 each, and we'll get 60 square feet. And the last of the weird easy problems, here is a chessboard. It's made with 64 squares. Half of them are black and half of them are white. So half the board is black, half the board's white. If the whole board is 50 square inches, what's the area of just the black squares? And this one's pretty easy too. We just take the whole area and divide it by 2, because we said that half of them are black. So 50 divided by 2, and we get 25. Why are these important problems? Well, they bring up an important set of rules about area, and that is areas can be added and subtracted and multiplied and divided. You can use the rules that you hopefully instinctively knew how to do in those problems and apply them to more complicated problems. Speaking of more complicated problems, we're going to try to find the area of this blue shape. Now, this blue shape doesn't even have a name. How are we going to find the area? That's not a rectangle or a circle or anything like that. In fact, it's not even convex. This is a concave shape. Remember that vocabulary word. If you think back to when we first introduced concave shapes, what we said we'd do is we would never talk about them. We would just take a shape like this and turn it into, instead of one weird concave shape, two shapes that we're familiar with. So if we want to know the area of the whole thing, let's just find the area of the red rectangle and the yellow rectangle and add them together. It doesn't have to be the way I've broken it up here. You could break these up this way, or if you really wanted, you could break it up into three rectangles. But any way you do it, you find the area of the parts of shapes that you're familiar with and simply add those areas together. So in order to do that, though, we're going to have to be able to find the length of either this side, or in some cases, we might need to find both. So we got to find some missing measurements. This should be pretty easy, I hope. If we want to find the length of that red segment, no problem. We got to look at the sides of the rectangle. And remember the rules for rectangle, that the opposite sides are congruent. In other words, if this top part is 6 and this part of the bottom is 3, then this other part of the bottom, that's got to be the same length as our missing side. These two on the bottom, the 3 and the question mark, have to add to the 6. So that missing side is going to be a 3. We do the same thing with this missing measurement. Well, this side over here on the left has to be 5. This part of the right is 2. So this missing part, which is what we're looking for, would have to be what? It's got to be 3. So now take this shape, break it up any way you want. You may need some scratch paper, and find the area of the whole thing. Depending on how you broke it up, if you did it the way on the left, you might get 12 and 9 for the two rectangles. Or if you did it the way on the right, you might get 15 and 6 for your two areas of rectangles. But it doesn't matter, because when you add them up, we end up with area of 21 feet. 12 plus 9 is 21. 15 plus 6 is 21. Either way gets us to the same answer. Just to point this out, we could do this problem a different way. Instead of breaking it up into rectangles, we could instead find the area of this entire square. 5 times 6, that would give us 30 for the area of the big part. And then simply subtract away the part that's not there. Subtract away this little rectangle. 3 times 3 is 9. And when we do 30 minus 9, we'll still get 21 square feet. So when we see problems that look like these, we're just going to break it up into the shapes that we are more familiar with, and then either add and subtract those areas. Speaking of which, for these three problems, which is the one that you'll have to subtract to find the area? Right, it's number 3. We take the area of the big gray square, subtract away our rectangle, and subtract away the little white one on the inside. In the other two problems, when you're trying to find the areas, you just break it up. And there's always more than one way to break these up. Here I have an example method, but you break it up into rectangles or other shapes, things that you know how to do. You look for what looks like it's easiest and makes sense to you, find the areas separately, and then simply add them together.